Welcome to yet another exciting educational video brought to you by Upvision Concepts Academy. So we are still on IGCSE Physics. In this series, we're looking at graphs in physics, how to plot and read and extract the meaning. So sit tight as we proceed to enjoy this lesson. If you haven't subscribed to our channel, kindly subscribe and get more of our videos. So we're going to be looking at the following objective in this lesson. The first is to plot scientific graphs neatly and accurately using experimental data. Second objective is to identify the dependent and independent variables correctly. Thirdly is to draw best fit lines or straight or curves to represent trends in data. And fourthly, to calculate gradient, slope, intercepts of graphs. Others not on the board. The fifth objective is to interpret the physical meaning of graphs and intercept in physics experiments. And lastly, use graphs to make predictions or check proportionality between quantities. So the first thing we'll look at is the conceptual explanation. What are graphs? What are graphs? So graphs are actually powerful tools in physics because they help us visualize how two quantities relate. So for instance, I have current and voltage. Let's say this is graph, this is the x-axis here, and this is the y-axis. Normally represented on a plane, a Cartesian plane, where these are positive y-axis and this is a positive x-axis. So if I were to represent the relationship between voltage and current, where V is on the y and I is on the x-axis, there's a straight line graph drawn. This straight line graph represents the relationship between the voltage and the current. It shows one thing, that as the voltage is increasing, so that the current is also increasing. So this is like a hallmark of a straight line graph. So like I said, you have the axis and the variables. The independent variables are the ones you control. Like as I said in lesson 1, the independent variables are the one you control. The one you just give values so that you can get observe a change in the corresponding dependent variable. So example of independent variable is time. You have voltage, or you have mass. And for dependent variable, this is the one that you measure. It actually goes on the y-axis. So the dependent variable goes on the y-axis, while independent variable goes on the x-axis. Okay. So in plotting the graph, we'll do the following. The first is for us to choose appropriate scales for both axes. We'll choose appropriate scales for both axes. Meaning that we'll look at the divisions, the calibrations of the x and y axis, and you mark them accordingly. Then number 2 is to label each axis with the quantity and units. Label each axis with the quantity and units. So if, for instance, I'm doing the voltage and the current, this is volts and I is ampere. So we'll label the axis clearly, because for your exams or for proper practice in physics, ensure that your graph carries a legend, a label. Okay, so the third point that you should note is that you should plot each data point with a neat dot or small circle. Okay, put it on the board. Plot each data point with a neat dot or circle. What do I mean by that? If, for instance, now I read a value here, I put a dot. I read another value, I put a dot, dot, dot. This dot is what I'm going to join to form my straight line graph. And this dot have two references. It has a reference on the x-axis, on the y-axis, and a reference on the x-axis. You understand? So this one is likely the same thing. Okay. So finally, number 4 is to use a sharp pencil and ruler. Use a sharp pencil and ruler. So to join the dots. So just avoid using free hand. Avoid using free hand. Best practice to use pencil and ruler to join the dots. Avoid using free hand. Okay, don't just trace, don't just draw it like that. Unless the relationship is a curve. So you can, the only way you can use free hand is when the relationship is a curve. Okay. Relationship is a curve. Okay. So how do we get our line of best fit? So a best fit line passes as close as possible to all the dotted points. Passes as close as possible to all the dotted points. Okay, I will explain this. Okay, so if I have the x-axis and the y-axis, for instance, the y and the x-axis, and I happen to get marks like this. So the best fit will be something like this. Okay, I'm using freehand, but I'm supposed to use a ruler. But just join the ones that are joined, and anyone that is scattered should scatter symmetrically around the line. Okay, so it doesn't have to go through all the points, but don't do the one that you will just draw like this and leave out these other ones. Let the ones that are not on the line scatter symmetrically around it. So I have like 2 here, I have like 3 here, I have like that is outside the line, maybe 1, 2, 3, then 1, 2, 3. So you see that I'm trying to draw best fits at the center. You understand? So it doesn't have to go through all the points. So the points should be roughly evenly scattered, above and below the line. So if data shows a curve, draw a smooth curve. So for curve, just draw a smooth curve. So you just draw, if it's curve, draw a smooth curve, on all the dotted lines. Just join it with a smooth curve. But for straight line relationship, get the best fit. The best fit have to be a line that is at the center of all the scattered lines, dotted points. So the gradient is a quantity we measure or a parameter we get out from a graph that shows relationship between the change in y axis and the change in x axis. So gradient is a quotient ratio, or say ratio, between the change in y over change in x. Now, denoted by this change in y over change in x, or you can say y2 minus y1 is over x2 minus x1. Okay, so actually these are actually points on the graph. If, for instance, your graph looks like this, I have a straight line. Okay, so this is y and this is x. So at every point in time, let's say I want to get the gradient at this point and at this point. So if this point is the 2 and this point is the 1, this is the first point, this second point. Now this first point, point 1, have 2 references on the x and the y axis. So the reference on the y-axis is known as y1, and the reference on the x-axis is known as x1. For this point, the reference on the x-axis is known as x2. The reference on the y-axis is known as y2. So at every point, there are two Cartesian coordinates representing, we call them coordinates, representing that point. So if I had to find the gradient at point 1 and 2, I will say y2, which is the value of y at this point, that's traced to this side. This is y2. If I trace it to this side, I get the value of y2. You understand? Minus, for this point, y1, if I go here, I trace it, I get y1, minus y1 all over. Then for this point, if I go, if I go, for this point, if I go down here, I get x2. And if I go down here, I get x1. So it is x2 minus x1. So this is how we get it. Whatever value you read on the coordinate, on the line, that is what you are going to use as the value to calculate. So physically, the gradient often represents a constant. So it's a constant. It doesn't have any units. It's a constant. So if, for instance, I'm measuring two quantities, I'll just have a constant value. It does not change. If I take the gradient at this point and the gradient at this point, it's going to still give me the same thing. So it's a constant. For Ohm's law graph, we will plot V versus I. V is voltage, I is current, right? So the gradient is resistance R. It's a resistance R. So for Hooke's law, if we are plotting the graph of force and extension, for instance, force versus extension. Force is in Newton, extension is in meter. The resistance is known as the spring constant K. Sorry, resistance, I mean the gradient is the constant K, known as the spring's constant. So there's a concept known as intercept. So intercept is the point where the line cuts this vertical axis. The point where the line cuts the vertical axis. Okay? So let me take this off and explain intercept very well. So if I have the plane, Cartesian plane, I have the vertical and the horizontal axis, for instance, and I draw a line. I plot a graph, and the line goes like this. It goes like this. So intercept actually is the point where the line cuts the vertical axis. Understand? It can either cut it on the positive or the negative side, but this is the positive side. So whatever value that you have there is the intercept. So you can tell the type of relationship you're having. So the y-intercept is where the line cuts the x-axis, okay, at 0, at s is equals to 0. Okay, so this is another definition. So it cuts the axis of y-axis where x is equals to 0. Very important you put that. Okay, so it may represent initial condition, e.g. velocity, initial velocity in a velocity time graph. Okay, so so again, the y-intercept is where the line crosses the y-axis. Here, x is equals to 0. That's the condition. Please take note of that. Okay, so we're going to be interpreting graphs. You look at graph and you can tell what relationship or the type of relationship. So if, for instance, you see a straight line passing through the origin, so this kind of graph is known as direct proportionality. So if you see a straight line, but not to the origin, it's linear, but not directly proportional. And if you see a curve, it's known as non-linear. So example of a curve is quadratic, inverse, or exponential. So this is really handy when it comes to interpretation of graphs. Okay, so we're going to attempt this example on the board. It says an experiment investigates how force F affects the extension X on the spring. data is collected below. So these are the data. 0, 0, force is 0, extension is 0, force is 1 Newton, extension is 2.0 cm, force is 2 Newton applied, extension is 4.0 cm experienced, force is 3 Newton, extension is 6.1 cm experienced, force is 4 Newton, extension is 8.0 Newton cm experienced, and force is 5 Newton, extension is 10.0 cm experienced. So we're asked to plot a graph, plot F Newton on the x-axis. So you just do your graph like this. This is the x-axis. The x-axis have force there, and the y-axis is the extension in cm. So this is the y-axis, extension E in cm. All right. So your calibration, this is 0 point. You calibrate your graph. The force axis, you have it as 1. Okay, let me use 2, 4. Or let me use 1. Let me use 1 unit. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So on the x-axis, I have 1, 2, 3, 4, and 5. Let me add 6. So if x is 0, 0, 0. So if force is 2, where is my force? If my force is 2, extension is 4. If my force is 2, extension is 4. Okay, this one is supposed to have the, let me use 2, 4, 6. 2, 4, 6, 8, and 10. Remove this so that you can see space. This is extension in cm, right? Okay, so and this is 12. So if my at 0, 0, this is starting point. So if my force is 1 Newton, my extension is 2. So this is my first marking. If my force is 2 Newton, my extension is 4. Second marking somewhere here. If my force is 3 Newton, my extension is 6.1 somewhere here. And if my force is 4 Newton, my extension is 8. If my force is 5 Newton, my extension is 10. So I'm going to be having a straight line graph relationship like this, cutting through. Please, this is freehand I'm using, but you have to be using ruler, to use ruler. And to get the graph, to get the, what's it called, the gradient, you're going to be using change in the y-axis all over the change in the x-axis. So gradient is equals to change in the y-axis and change in the x-axis. So for instance now, if I take my gradient at this point to this point, at 5. So I'm taking this point. This is my x extension. This is my y. This is my y, and this is y2, this is y1, this is x2, and this is x1. From here, y2 is this, and y1. Then x2 is this, x1. So y2 is 10 minus 0 all over x2 is 5 minus x1 is 0. So the gradient is 10 over 5, which will give me 2. The unit of this expression, gradient, is the ratio of the two units. So what I have as y-axis is the extension. So extension is in cm, and the x-axis is the force. So it is 2 cm per Newton. 2 cm per Newton. So this is the gradient of this particular graph. So in effect, I'll be able to check a graph, and we are seeing that graph represents the relationship between the two quantities in experiment. Then we saw how to the parts of a graph, the axis, how to calibrate, how to get your gradients, what the concept of intercept is. I'm going to leave a question, some questions in the comment section for further practice and maybe answers to go with them. So I hope this video has been informative for you. I'd like to thank you for viewing.